Our next talk is by Professor Talia from Calabria University, Professor in Italy. Professor Talia is working on cloud computing, parallel and distributed data mining algorithms. And his talk title today is Designing a Scalable Big Data Analysis on Clouds. Okay, finish.
Thank you very much, Mr. Chair. So thank you very much to the conference chairs and the conference organizer for inviting me here. It's really a pleasure to be here and to give a talk and also to meet colleagues and discuss about the conference topics. So my talk is mainly concerned with the use of cloud computing technologies and solutions for implementing scalable data mining. So the idea is to implement data analysis and data mining as a collection of services. And in this case, cloud platforms may be effectively used, effectively exploited for such a kind of task. So I will try to introduce the basic rationale of my research activities, of my research work, and then in the second part of the talk I will try to give you some examples of software systems that we developed according to this approach. So in particular the data mining cloud framework, the GS for cloud programming language, and the Nobodies platform. So as other speakers discussed before, big data has a set of properties that have been defined a few years ago, but from my point of view, one of the most important aspects of big data is the value aspect. So we may have a lot of data in our database, in our computers, but if we are not able to analyze such a kind of large amount of data, it's useless. So the point is, obviously the problems are coming from the high volume of data, from the velocity of data, because they are produced continuously, the variety of data and veracity and so on, but the real problem today we need to face is how to extract value from data, so how to understand what is important in data for us. So in this sense, it's important to speak about big data analysis or big data mining instead of using a very generic term, which is big data. You know, it's very particular. I don't know if you had a look at the first 3 or 4 pages report about big data, which is a Gartner report, and it's very interesting because you find the characteristic of big data, so you volume, velocity and so on, but the term big data is not in this report. So the term has been invented later just to find a keyword. You know, in computer science we are pretty accustomed to produce keywords every day. In some cases we confuse people, because if you don't know the keywords, you get confused and you say, oh my God, I'm not up to date. The same happens with deep learning. I don't know if some of you is working on neural nets, but what's happened in the past years is that people worked in the 80s on neural net were not accustomed with the new term, which is deep learning, and you say, okay, it's a new technology. No, it's nothing new. It's the use of neural nets on high-performance computers, on Watson and similar. So, anyway, what is important from my point of view is the analysis of data. Okay, you may have a lot of data, but if you cannot analyze them using, for example, single application, but in many cases single application or single task application are not enough. What we need is to have Obviously, distributed application or parallel application, typically in many cases workflow-based high-performance application for the analysis of data. So in this scenario, cloud computing may help and may be used effectively to efficiently run different classes of data, big data analysis application. So this is my perspective, and that's why I will speak about the idea of composing big data analysis application as a workflow on workflow of services on cloud platforms. So as I said before, big data today is huge because of computers. So computers were invented to reduce data, but at the end they are producing more data than expected. Okay, and as you can see, data never sleeps. We need to sleep during night, but everybody's producing data on the internet, on social media, and from experiments from everywhere. So it's very hard to handle with such a kind of deluge of data. Anyway, as I said before, volume is not important. What is important is value, and to extract value, we need to have scalable solutions. So the keyword scalable here is important because, you know, high-performance computing, cloud computing, cluster computing platform have the main goal to be scalable, so to provide scalability and speed up, scale up, because as the problem become big, we need to have a smart solution to reduce execution time, and also in this case, in some cases, to address the problems that are so huge that in some cases cannot be completely solved. Okay, so I put this small sentence by Reed and Dongara because I think it's pretty in line with the topic of this conference. So it's very important to put together edge performance computing and data analysis. Okay, so in this case I will going to speak just for a few minutes. Sorry, there is not so much time to go in detail, but anyway, we can discuss later if you wish, about data analysis as a service. So the point here is that we may use some cloud service models like platform as a service or software as a service as a basic mechanism for implementing, for example, framework for designing and executing scalable data mining application. At the same time, for end users, we can use the software as a service approach as a model to implement final scalable data analysis application. I will go ahead to show you some examples, but before giving some example, I just focus on the approach. So using the as a service keyword, we may say that we can provide big data analysis as a service, and this can be done both designing single KDD steps. So KDD is knowledge discovery database process. So pre-processing data, filtering data, visualized data can be implemented as single services on a cloud. At the same time, any data mining algorithm can be provided as a data analysis service on the cloud. According to this approach, all this collection of services can be composed to provide some sort of collective learning or parallel classification or parallel clustering task. So we can put together services running on a cloud or on a multi-cloud platform for implementing complex data analysis application, or for example, meta learning application. At the same time, using this distributed data mining patterns, we can compose data mining application as multi-step workflows. Here the idea is that any step of the workflow can be implemented as a single service or as a collection of services. So at the end, if we use this approach and we work in the implementation of any elements, any task of this big data analysis application, at the end we provide a sort of service-based framework for distributed data analysis. So, and this is very important because this allows also the use of reuse of data mining tasks that we implemented before. So anytime that we implement some solution, we can collect the solution in a sort of catalog of services, and we increase our ecosystem of solution for big data analysis. So in this way, we can implement collection of services for communities of researchers, or community of enterprises. At the same time, we can provide distributed analysis services on demand as people need on the cloud. And in this way, we can have big data analysis services accessible every time and everywhere, because if they are provided, they are offered on a cloud, they can be executed remotely, also from small devices. So in this way, we can use together mobile devices, so pervasive devices connected to a backbone composed of cloud platforms. So as you know, this is a very limited list of some data analysis tools or framework that are available for doing big data analysis on clouds. So perhaps you know Spark or Sphere and Sector, Swift, Mahout and others. I will focus on the system that we implemented, the data mining cloud framework, which is, has been defined as according to both two approaches, the platform as a service and the software as a service approach for the implementation of data mining application. This is just a flavor of the frameworks. The idea here is to provide a sort of graphical, visual interface through which the user may compose its big data analysis application. So in this case, the idea is that the system, the framework, offers a catalog of data mining tools, of data sets, of filtering tools, pre-processing tools, and so on, and the user may select from the catalog all these components and compose the workflow. This is a sort of very high-level interface to simplify the work of data analysis programmer. What is important is that in this kind of workflow, every element is offered as a service, and in case something can be run in parallel, the system identifies transparently data-driven parallelism and try to execute in parallel the different, for example in this case, the different branches of the workflow if they have no dependencies, okay? At the same time, we use a sort of array notation for the execution in parallel of some data mining task. I will give some detail later. Okay, so this visual interface has been implemented in cloud platform, providing a set of mechanisms for allowing the user to connect to a sort of web instances through which to compose the application, and then the exploitation of parallelism through the instantiation of different worker instances on different virtual machine of a cloud. So the user doesn't worry about the parallelism exploitation, but it was worried only about the definition of its application. So this is a sort of schema of how the different elements of the workflow are assigned to a task queue, and then from the task queue to the virtual compute servers that are obviously virtual machines on a cloud, and the tasks are run in parallel when possible, and they access data as input data for the analysis, and they produce data that are stored in tables, in blobs, and so on. Okay, so another interface that we provide in the same environment, in this data mining cloud framework, is a sort of script-based data analysis programming models, which is pretty similar to the visual interface. So the semantics of this language is similar to the graphical programming interface, but the interface is different because in this case the user use a sort of JavaScript dialects for composing his application. So in this case, a more expert programmer may prefer to use this kind of interface. So in this case, it's possible to include the collection of data, the creation of data, and the parallel execution of data mining tools. I will give you just an example. So in the bottom part of the slides, you see a workflow, a data analysis workflow designed using the graphical interface, and on the top of the slides you see the same program but designed using the JavaScript for clouds programming language. So there is a direct correspondence between the instructions, so the operation of the JS for Cloud program and the group of graphical elements that we have in the visual interface, programming interface. So we may identify how, for example, in this case we have a double for, a nested for that has been implemented in parallel in the data mining cloud framework, and the same thing is expressed using the array notation in the graphical part. Anyway, there is no time to go in detail on that, but just to show you some very simple patterns. This, for example, is a pipeline partner that could be used for the implementation of pipeline data analysis. We have also, for example, in this case, this is a very simple way to implement parameter sweeping parallel application. So in this case, we run in parallel 5 instances, but we can have also 50 instances of the same program on a database, data sets, an input data sets, which is collected and analyzed by the J48 classifiers, and they produce in parallel 5 classification models. So this is a very simple way to implement such a kind of application. Another similar thing is the input sweeping patterns and so on. Anyway, this is another case in which you can see that very simple master worker pattern can be implementing both using the programming interface and the visual interface. At the same time, we provide a sort of monitoring interface during the running of application on a cloud, because so user can follow the execution of the different operation in the workflow. So in this case, the green items show that operation have been completed. The blue one show that the execution is at this point, and then the red one means that they need to be executed. So the user may also follow and monitor the execution of its data mining workflow on the cloud. Anyway, Using this kind of platform, we implemented many applications in different areas like finance, health, network analysis, and so on, bioscience, smart city application. As I said, there is not so much time for going in detail on that. There are many papers that describe that, in case I can provide them. I just give you a feeling about the car trajectory pattern application. So here the problem is to try to identify how car moves, car move in a big city, and this is a big problem. So sorry. I prefer to go ahead and then I will be back. Okay, so this is the way in which we can analyze trajectories of users to discover movement patterns and movement rules. In this case, the application has been run analyzing the movement of car in the city of Beijing in China. This is the graphical representation of our program, and it's very simple. Obviously, any graphical elements in this workflow represent some service. So I mean some data analysis service. At the same time, the data sets, that the input data sets and the output data sets are also included in the workflow. So just to list the main operation that we did, we started from the detection of frequent regions. So the region densely passed through by the cars. So we used a density-based clustering algorithm in this case. Then we identified the areas. Then we combined the trajectory data to construct dense region where the trajectory belongs to. So we have a sort of combination of trajectories to select and to identify areas where people move, and then at the end we produced some patterns, so some rules of movement in the city. So understanding how the traffic moves in a city, this is the abstract definition of the workflow of the application. In our case, our formalism allows to compose in a compact way this workflow, just to show you. Okay, we run this, for example, on 128 machines, but this could be also, so it's possible to use also different number of parallel tasks. At the end, we got the rules, but at the same time, we got some visual representation of traffic in the Beijing city, so you can look where, in which areas we have the most dense region of cars during the day in different day times. So I go back just very quickly to another application, not to go in detail on the application, but to show you the scalability aspect. This is just the KDD Cup 99 examples. So in this case, we used up to 64 virtual server on a cloud. So what is important about scalability is to try to have applications that exploit Speedup. So in this case, for example, we reduced the execution time for 4.5 days on a single machine to 2 hours on 64 processors. This is very important, not only to get the results very quickly, but in data analysis it's very important because in many cases you need to run again the application changing some parameters. So you may imagine that getting the result after 4 days is different than getting the result after 2 hours, because you can rerun the same application several times in a day with different parameters and trying to identify the best way in which the analysis can be done. And this obviously corresponds to some speed up value, so nice speed up. This also can be measured in terms of efficiency, and efficiency in this case is pretty nice, because 80% on 64 processor is pretty good. Okay. So in the case of the trajectory analysis application, we also have some speed up figures, and in this case we reduced the execution time from 3 days to 1 hour and a half, and also in this case it's very important to have the possibility to run again several times the application. Here we did also some more detailed analysis to identify the sequential part of the algorithm and the parallel part of the algorithm, and you may see that the read part here, so this part is the sequential part that should be reduced in this application. So this means obviously that there are some sequential part of the algorithm, and you may see that the parallel part there, and also the sequential part, which is the final part of the workflow. So now we are working on trying to exploit parallelism also in this part, just to reduce the red part of this graph. Okay, so I'm going to conclude, but before to conclude, I just want to show another examples of another tools which has been implemented on a cloud for the implementation of big data analysis application. In this case, Nobodies is a high-level tool, so I might say higher than the data mining cloud framework, because the idea here is to provide a scalable tool for end users. So to user that doesn't need to have expertise in programming data mining or data analysis application. Nubitics offer only a graphical interface, and through this graphical interface, users may select or store the data, load data, and then select a set of algorithm, classification, regression, clustering algorithm, and run the algorithm on the data they have, and getting some analysis at the end. So the front end of this tool is composed by 3 sections: the dataset selection, the task selection, and the model presentation, so the result presentation. So we have the first window for the dataset management, the second window for task management, and at the end the last window for visualization of the data analysis model which is produced. So in this case, user may select the data, load the data inside this tool. The tool is available to load and store data in different formats, so standard formats, and some other formats can be added in case. Then after the loading of data, data mining task can be selected. So among the set of tasks that are offered in the environment, the user may select the task, select the attributes of the data sets he is interested to analyze, so do some very simple pre-processing of data, and then run the task in parallel. running the task in parallel will result in some output. The format of the output obviously depends on the kind of data analysis is operated. So I mean classification, clustering, or regression. So we provide different graphical representation of results. So in this case, the user doesn't need to program anything, but just using the interface can do that. So also in this case, we have some scalability results, because as I said before, scalability is one of the main goals of our research activity. And so in this case, for example, in this example, we reduced from 5 hours to 3 minutes the achievement of results. So this also results in some speed up. Interesting value. So just a few final remarks. We are using this kind of tools, as I said before, in different application domains. One of the interesting domains is, as the previous speaker said, the social analysis domain. We are doing very interesting social analysis application, so mining using clouds and this kind of environments. And also in this case, scalability is very important to reduce execution time. But at the same time, I would like to mention that in the area of scalable big data analysis, there are many open research issues. This could be a problem, but at the same time, it's an opportunity, obviously, for us that we are a researcher in this area. So just to mention some of them, we need to have, how to say, useful programming abstraction for big data analysis. As you know, in many cases, people use MapReduce. Okay, so MapReduce is fine, but it's fine only for a certain class of application. Okay, so it's a sort of simple patterns that is very effective when you have regular algorithm to run. But when the algorithms are not regular, MapReduce doesn't help. So the idea to have, for example, workflow-based or data flow-based mechanism and abstraction is really important. So this is an area in which to investigate. At the same time, it's important to provide a mechanism for the integration of data sources and data framework and tools for data analysis. So typically every team, every company implements its tool and doesn't care or doesn't much care about the integration of this tool together. And this is another important aspect. So putting together tools and frameworks may help community of users and community of researchers. At the same time, interoperability of the framework is very important. You know, in the cloud area, lock-in is a problem. So every cloud provider try to keep the user, try to keep the client inside. So interoperability, I think, is a mission for researchers, because we need to provide solution to allow users to use different clouds platform, different HPC platform together, or move application from one cloud platform to another. Okay, so as I said before, my feeling is the area of big data analysis, the integration of big data analysis with HPC, cloud, and then exascale platform is a very promising area, a lot of things to do, and a lot of interesting results that could be obtained. I just give you a flavor of what we are doing. Here are some publications, some books, and some papers. In case you need, I can provide some references and we can discuss of that. So thank you very much.
Thank you very much, Dr. Talia. Okay, we have a very limited time.
I have two questions. One is, I am curious how you manage to follow the cars in Beijing. You say by mobile phone use, but how did you know it was in a car? I have a second question. It's not as bad. The question is, in the timing graph that you had for the number of servers, which went up to 64,
Yeah.
may I suggest that if you use the criteria of price,
Oh, yeah.
maybe 16 servers would be better than 64. With
Yeah.
massive numbers.
Yeah. Okay, so thank you very much for the question. They are very interesting questions because they pose very big questions. The first one is about the availability of data. So everybody speaks about big data, but many people have no access to big data. In this case, the source of data is coming from the taxes of Beijing. Okay, so going in more detail. So we have a huge data sets of data coming from taxes, and these allow a very good monitoring, very detailed monitoring. So I didn't say before, it are not all the cars of Beijing, but you know, it's a significant examples because taxis moving around the city all the days. Mobile phone providers have a lot of data, and they typically sell this kind of data. It's not easy to get their data, but they are very good sources to understand social behavior. At the same time, social media are important. We did a few research activity using Twitter and Facebook data. Even if these data are not, how to say, regularly provided, because everybody can post or tweet whenever he wants, they are very, I think, precious. So at the end, we did some experiments in Paris, in London, and in New York. And my feeling, at the beginning, I was very doubtful. But at the end, I see that using social data, you can discover interesting things. In terms of scalability of prices, okay, I have no slides in this collection, but I have some slides because one of the activity for example, about Nobodies, we are doing this activity with a startup, so we are also selling Nobodies, and this is exactly what we show to the clients, how they spend much less using more processors, so having results in less time. So you are completely right. Thank you.
Okay. Okay, Victor.
Just one question. Yeah, you mentioned the interoperability challenge.
Big issue.
So I don't know if you have any thought about how to face that kind of in a democratic environment where you cannot force everybody to use the same API and so on.
Yeah.
It's going to be just a big mess, or the right way to deal with that?
Yeah, you know, also this one is another very big issue. We have no time to go in detail on that, and perhaps a panel on that would be interesting. But anyway, just to summarize, we need to have interoperability at the data level, and we need to have interoperability at operation level. So you mentioned it, API. So API is a really important thing. I think that the research community, mostly, more than the industry community, which is not very happy to do that, unless they see some dollars, some money. But anyway, the research community should improve interaction on that. So try to set up some, I don't know, committee or community in general. For example, the Apache effort is really, really important. So try to adhere to this kind of community and try to work together, providing some standard or pretty standard API. So I think it's a responsibility of the research community. In terms of data formats, many things has been done, but also in this case, I think that if researchers work in the area of data interoperability, providing some standard or common format, they will be successful and they will make happy many people in the research community. So sorry for the very short response.
Okay. Only one other question. Yeah, that lady. No, here.
Thank you very much. Is there any mechanism for stream processing in the MCF benefit from dynamic scalability of cloud?
I'm not sure I catch it. Are you speaking about
Yes.
extreme?
Processing.
What do you mean extreme processing?
Streaming processing.
Oh, streaming processing. Ah, okay. Okay, thank you. Sorry, I didn't hear very well. Actually, the environment, the framework in this moment, in its current version, have no specific streaming facility. But just to show you how streaming can be handled in a workflow, this can be easily done because instead of having input data sets, what you need to provide are some services that getting data from some source, like laboratory machine or some social media or some web sites. So the only way to do that is to implement one of the tools that is not available today that get data from some source. Then the rest, it works. Thank you very much. Thanks.
Okay, thank you. Please,
Thank you.
We are behind the time, so we will have a short break for 20 minutes and we will come back here